Okay, so let's start. First of all, I would like to thanks to our sponsor today, MorningStar, Atrinet, and T-Core. Thank you very much for this exciting panel and event. So I would like to introduce our panelists today. Myself, Roy, I'm coming from Atrinet, leading the customer care and pre-sales support. Together with me, we have Christophe Chavre from TIP, Roy Silon, Atrinet VP Technologies, Alex Secato, Director of Sales of GenCell, Brad Relwood from MorningStar Product Manager. Sorry. Thank you very much for coming. So this is our agenda today. We are going to discuss in this panel on the management aspect of rural site configuration management. This is basically the last panel that we have, and we are going to focus today more on the management aspects in rural site. So we will have Atrinet to discuss it, as well GenCell and MorningStar. So the first topic for this panel is an overview of the primary challenges in rural site management. For this, we have Christophe that will take over and start the discussion.
I have a brief overview, like to put things in perspective. So maintenance, and we're probably going to use the word NMS, network management system, in that discussion. It's something that is well known in all the networks have some level of NMS. What really makes the rural NMS challenge, it's we need to have to monitor and maintain quite a few different nodes. And if we look at what we just did as part of the rural site configuration plug face, we actually enabled multiple vendors for the RAN, multiple vendor for the satellite modems, but it could have been also, it just happened that we only had one, it could have been also multiple vendor for the power system. And that desire to have multiple OEMs for each of the components really came from the operator that help us define that site configuration, because they don't want to be locked in. And remember, all what we're doing in TIP is enabling the disaggregation or fighting, or the other way of putting it, fighting the vendor lock-in. So it's great, but that means that the NMS needs to be compatible with a variety of nodes and even a variety of variant of each node. And that's really what makes it very critical, as we're going to see later on. And the additional challenge, and again, we're going to see that during the panel, is, well, not so we don't necessarily know the site reliability until it's too late. And when I say that, it's, well, if we run out of power, everything shuts down. So there is an important part that we need to make sure that we will guess that the power is going to be cut off in a while, and that gives us time to react. A few other aspects that I'm sure we're going to mention them also. It's, well, an NMS should also help us reduce the cost and OPEX, probably more than CAPEX, but maybe we're going to talk about that. And it should help us minimize the number of site intervention. So when we talk about zero-touch provisioning, ZTP, that's also critical in the sense that if we have a good zero-touch provisioning, and Rajesh, the previous panel, was calling that automation, that's really critical in the sense that it allows us to send maybe less qualified technician to the site to deploy, and again saving on the resource side. But I'm probably getting ahead of myself, so I will turn it back to you, Roy, and you can take us through the first discussion.
Okay, so indeed, this is our first discussion to the panel. What do you see as a main challenge in a management of rural site? Now it should be okay.
I'll start because I think I already gave my view in the introduction. It's really dealing with multiple type of nodes, multiple type of variants, and by different OEMs, and in a condition that may not be fully reliable.
Yeah, indeed, and in a rural site, especially, we have a different type of vendors, long distances. So indeed, management is a crucial aspect. This is how we see it as well. So Roy, you can.
Yeah, I think in general, it's the multiplicity of dimensions. So as Christophe and you have already mentioned, we have different vendors. We have different elements in the rural sites. It's also very interesting that we have the power management system that's usually is out of scope in normal management solution for telecom. But here it's well inside, and it should be considered because it's a big part of how we can reduce the OPEX for rural site management. We have different APIs. And I think also one of the major challenges is having a management system that can adopt introducing new types of vendors or new management or software versions of the different vendors. Let's say starts to decide to use NetConf instead of CLI. In some solutions, you will have to do a lot of work around that. So the management solution has to be very extensible and adaptable to support whatever variants are coming inside in order to reduce CAPEX and OPEX.
Thank you very much, Roy. Alex, how do you see it?
Yes, hi. So from my perspective, really, when we're considering the power aspect of the solution is that, I see that there's a lot of solar panels and batteries and diesel generators that are typically used. I know we've had that discussion in some of the panels previously yesterday. But, the problem that I typically find with a lot of these applications is when you're relying on Mother Nature to provide you 100% of the resources you need on a regular basis, it becomes very challenging. Temperatures are always a problem with batteries, whether high or low. Maintenance, depending on the type of battery that you're using, if you're using lead acid batteries, then you have a problem with theft. You have a problem with drying out the battery. So maintenance always becomes a big issue. And the biggest thing is that we need to find a solution that will give you power on demand and try to keep the equipment as protected as possible. When we're talking about rural sites, theft and vandalism, which is another topic that was discussed yesterday, it's a major, major problem. So you need to also be able to find a way to protect all the equipment because, as Christophe mentioned, the power is at the core of the entire operation. Without the power, really nothing else matters. So we need to ensure that the power is secure, that it's reliable, that it's in simple design, and that you're able to manage all of the sites, not just the 1, 2, 5. I mean, if you're operating thousands of sites, you have to be able to understand exactly what's happening in real time so that you're able to make informed decisions about what resources need to be deployed and when they need to be deployed. So those are some of the biggest things that I find related to the power aspect of rural sites.
Thank you very much, Alex. Very interesting. Brett, how do you see the management aspect in regards to power?
Yes, well, I think from our perspective, I mean, I agree so much with, what I'm hearing already, and in that I think the first place we start in terms of how to get best handle on the management is, of course, define, tight system control, of course, the openness and the integration of the different operators, the different equipment that's at the site. And then I think the next step we do is really looking at what are the key performance and data that you're going to actually look at in the system, because it's not always the data that you see at surface value. You've got to sort of see patterns over time, know what to look for, what notifications are you going to put in place, because I agree with Alex. Mother Nature is at hand, and it's not 100% perfect. So you've got to predict what's going to occur, what can go wrong, and sort of see it coming before it actually occurs. And there's usually things that will show you or lead into that problem well ahead of before it actually becomes a reality. And then lastly, having a plan B, being able to manage your loads actively, disconnecting, reducing power, may affect customers, but it's going to keep the overall site health up, and also possibly having, hybrid generation sources as well, because with that, you can sort of balance out your strengths and weaknesses and get something that's going to give you the best of what you need in all circumstances.
Thank you very much, Brad. And as we know, power is just one aspect. In a rural site, we have at least 3 types of technologies. We have the eNode B, we have the VSAT modem, and we have the power. And the day-to-day management, the day-to-day operation indeed is a crucial question on how to simplify it in order to do it right and to be always aware to what is going on those long distances sites. So Roy, it's taking us to you to discuss a little bit about Atrinet and what you are doing there.
Yeah, hi. So hi everyone. So we at Atrinet are coming to the whole total site solution as a software vendor who is mainly doing management solutions. We have a very modular platform called NetAce, which is a multi-vendor, multi-domain management system supporting the full plethora of FCAPs and enabling the network operators to manage devices from different vendors, from different technologies, all based on models that can be easily generated by the users, by the network engineers, the network operators, but also coming with a preloaded library of models. And the idea is that this allows us to enter and give a value in a lot of different domains. Originally, we came actually from the transport domain, where we are doing management of optical and IP/MPLS management. But our capabilities also allow us to do a lot of management functionalities in the access domains, wireline and wireless. And one of the very interesting domains that we've entered recently in terms of supporting it is the rural site management. And here basically, originally this slide actually, when prepared by someone in our organization, it was written, it started with the problem, managing many vendors with many variations. But that's not really a problem. That's actually one of the key things that TIP and everyone here is pushing to, allowing the operators to have a wide variety to pick and choose between vendors and allow the vendors to interoperate with one another. So CapEx, for example, can be greatly reduced, and also feature development can also be sped up. This is basically allowing to break up the monolithic vendor lock that is prevalent all around the telecom industry, and is usually very bad for the operators, not good. So one of the nice things in the total site solution endeavor from TIP, and also everything that is being done in the Plugfest, is actually making sure that the total site solution can be deployed using different vendors for each of the main component: satellite modem, power supply management. allowing basically the operators to choose, for example, the vendor that is fit for their needs, both in terms of functionality and in terms of price. Sometimes prices differ from region to region, and they are also safe in the knowledge that they can basically have a leverage and they can replace vendors and do not break up the solution because everything is working together. But every blessing has a curse, or every curse has a blessing, whatever, which side you want to look at it. And this brings a little bit of a problem from the management aspect. So on the one side, you have these goodies. It is not a problem. We have many of those that can bring also different types of equipment, different capabilities and features, different management APIs sometimes from vendor to vendor, and sometimes even different software versions or different devices. The same vendor, you have different management APIs. And on the other hand, you want a single management solution to manage all of this in order to make your life easier, in order to have one technician or one operating team that would be able to do the whole management perspective of this. So this is how we envision the RMS, or Rural Management System, or Remote Management System. The RCAN stands for many ways. And the left side, for those who are not fully familiar and just found their way into this event or panel, this is basically how a site looks like. This is basically the solution. There is some kind of a standalone power supply, because in rural sites we cannot rely on actually existing power infrastructure. So in this case, we have, of course, solar, for example, and for this we also need a solar power management solution. There is an eNode B, and in the future, probably also other types of run, maybe a completely distributed 5G unit, of course, depending on the price and what vendors will have to offer. And we usually have the satellite modem to break the main rural problem, which is a lack of either a wireless or a wireline connectivity. And what you need for all of these different components are deployed in hopefully hundreds of or even thousands of sites for the big countries with big rural areas. You will need a one-stop shop that would give you the main functionalities that you need. And this includes the ability to discover the site, the ability to monitor it, the ability to configure the site, the ability to receive faults, to receive all of the counters that would allow the maintenance, to do trend analysis. You will need all of this in a one-stop shop for all of the different elements together. That's the way we envision things. If you look at the sort of immediate financial attributes that come along with this, it means that you basically can save on OPEX and CAPEX from a lot of different perspectives. First of all, you have one single system instead of different ones. Usually that means immediate reduction of CAPEX due to licensing costs. It means that in terms of management perspective of the network operation team, you can have a much smaller team. If the management solution is good enough and really encompass all of the things, it can allow you to automate a lot of the different management functionalities and save up, first of all, the cost of sending technicians on site, and on the other hand, it can help to reduce the technical skills of the technicians themselves, or of the operating team, because the system is smart enough and allows them to do a lot of zero-touch functions on their own. So they just have to click a button, or they just have a knock view to what's happening in real time in the site. They don't have to go inside to shell, they don't have to debug a lot of stuff, and this greatly reduces their amount of work.
Thank you very much. And this is basically indeed the OPEX aspect that you just mentioned, taking us into our first poll question. So guys, in the right hand, you have the poll. Our first poll question is, do you see multi-vendor single NMS as a viable OPEX reducing factor? Please put your votes. Thank you very much. I can see that the data come in, and I can see around 80% is for the yes, a major issue. And thank you for the votes. 76% for the yes, 5% for the no, and 80% from I'm not the relevant person to ask. So indeed, that multi-vendor is an issue. So Roy, back to you. How you are tackling it, and how you indeed can reduce the OPEX in this area?
So first of all, I am happy to not be surprised.
Yeah. Exactly.
I see that, and again, I'm not surprised, because in the last few years, I think the industry has understood that, first of all, management is part, and management for the entire network, or at least for an entire domain in one single place, is mandatory. Now, if we go a little bit into really our experience and data that we have, and also data from available resources, and we try to attach some facts and numbers to it. Why is this so important, and why this can help? So let's take a look on a few sort of day in the life, or a week in the life of a technician or managing some rural site. So we start at the beginning. Basically, there is the whole setup of the installation, day 0 or day -1, if you want, of the site itself. You want to reduce this part to a minimum. Basically, I'm envisioning maybe parachuting everything eventually, and not having anyone really on site. But you need to have someone drive and do the manual installation. Basically, and there are actually other companies at the event, like Cornock, for example, that have some cool stuff, like trucks that are going inside the rural stuff and just offloading the complete rural site. Everything looks like science fiction, opening automatically, robotically. You have the spun up, and that's it. And that's really where you want to stop. How can you do that? By, from this point on, having a remote, cloud-based, hopefully, a management solution that is automatically discovering the site based on some immediate sort of day 0 connectivity from the satellite modem to the all elements of the site. And from this point, this management system can take care of all the day 0 and day 1 configuration. This is zero touch. This means that instead of having the technician on site for a day, he can be there only for 1 hour, and he has to be a not very technical technician. He can be a delivery man, not a real technician, saving up a lot of costs. Then basically, if we go into additional day-to-day management capabilities that can save a lot of money and headcount, or experimented headcount, you have your various discovery, configuration, and monitoring aspects. So the days of a technician or a network operating personnel going manually into the shells of the devices and reading the statistics and doing the configuration through there, I think is going away. And it should go away, especially when we're talking about complex operations and especially when we're talking about scale, which is exactly the rural site case. So you need to have a management solution that enables you to do all of these operations. If we're talking about, we see the industry evolving, you must have a management solution that knows how to manage both legacy and new type of technology. But if I'm being more focused, you must have a management solution that knows how to manage disaggregated solution. So NOS that is running on some white box in combination with a proprietary devices, because this will be the future. It will be a mix of these elements. The management solution must be able to manage all of these. And of course, also if we're talking about the technology, today rural site is mainly focused on 4G, but we envision that maybe in the future, 5G will be in place as well. So if we look on all of these, you can see some of the immediate major savings, but if we go to the next slide, based on real data, we've given you here an actual OPEX saving estimation. This is basically something that is relevant to remote management, multi-vendor solution in general, but also very, very applicable, of course, to rural site. In rural site, if you look at it, actually the bigger part of the operator cost is OPEX. It is more than 40%, and it is the biggest part. There were other panels around that, and you can see the slides. So this is the main challenge. And if you look at the OPEX itself, you can see here that basically the average of having a unified, well-placed management solution that really covers all of the required aspects can bring up to an average around 40% in saving. Let's look at, for example, two interesting things here. So the big ones, you can see the 60% and the 50%. So the 60% factor is the technical level, which we already discussed. I think this is pretty obvious. Now let's look at the 50% in average reduction, which is maintenance. This is not easy to achieve. If you just have some management solution that enables you to do pings and read some statistics from the device, that does not cut it. Okay. You need to have a management solution that really allows to offload and automate the monitoring, the correlation, the faults, the specific events, not flood you with tons of faults, but really give you the root causes of what went wrong, and then you identify whether something really mandatorily necessitates someone going on site, or help you to automate a fix or a swap or reconfig to fix some problems. And this is the issue. Another, and I'll finish with this, basically very interesting, I think, reduction cost is the upper layer integration. Usually an operator would have different layers of management, and always at the top, probably some OSS and BSS systems, which are connecting to the domain controllers of the management system. By saying multi-vendor management system, it is not just multi-vendor towards the devices, it is also of a unified access to the upper layer to present a unified NBI. So you do the integration once, and then regardless of which vendor or which new device type you're onboarding, integration cost for the upper layer was indeed one-time cost. This is a key requirement of the management solution. So thank you, and back to you, Roy.
Thank you very much. Very, very interesting. And indeed, it's taking us into the second panel discussion, how to unify NMS multiple sites, elements, and vendors. So I'm really curious, Christoph, from your perspective, you basically see all the vendors in the Blackfest, testing everything. I would like to take it even from the first life cycle of combining all the vendors together. Do you see any value of a single NMS, even in the first phase of this testing, and then deployment, of course?
Yes, absolutely. And what we've observed during the testing, it's actually, we had basically one engineer dedicated for, and I'll talk more about the run in this case, for each run, just because they needed to know how to operate that run. The absence of unified way of operating all the runs actually forces us to have multiple people. And that's not something that the operator would be able to have. What feedback that we have from operator, it's, well, for their macro network, their urban macro network, they already have typically 2 vendors. So their maintenance personnel already need to know about 2 different operating systems, network operating system. If we had multiple vendors for rural, the feedback was, well, we might be able to learn 1 more, not 4 more. So here we have 2 examples from the operator, but also from our testing, that having one way of operating, it's very critical. And that's just for the run. We've got representative of other areas.
Thank you very much, Christoph. Brad, how you see it from your experience with actual deployment in the field?
In terms of unification of the systems, I mean, really, it's been about just giving a lot of support and providing a consistent profile with our products, at least, because we have a variety of them, in terms of getting consistent data, consistent terminology, information across all of the products in the same way and in a protocol that, excuse me, can be provided so that it can be integrated into existing systems. I mean, in our outside of telecom and renewable energy, there's a completely different set of data communications used for management, because there's kind of a different intent in mind, especially with grid connected systems. But in specifically focusing in industrial and telecom, we worked in a different way and with sort of a different data set and with different software providers to provide much better unification.
Thank you very much. Okay, good. So it's taking us into GenCell energy. Alex, stage is yours.
Great, thank you, Roy. And actually, this is a great segue based on the last question that we had earlier. But before we get to that, let me give you the poll here, which is power resiliency a vital consideration for rural and off-grid deployments? Question is either yes, no, or I don't know. So if we could get you guys to give us your insight on that on the right-hand side, I would greatly appreciate that. So it looks like at the moment there's about 90% saying yes, 0 votes for no, and I don't know 10%. So I pretty much figured that was the expectation of being yes. But the simple reason is that, as I mentioned earlier in part of the beginning question that we had, is that power is at the core of everything that makes everything else possible. As we've been discussing, is that in order to really manage all of these different sites, you really have to be able to have a software package that will enable you to understand what you need to know when you need to do it. I'll talk about that in just a moment. So just to kind of give you an introduction for you guys who are not as familiar with fuel cell technology, is that a fuel cell, think of that as a computer that generates power. Through a chemical reaction process between hydrogen and oxygen, we're able to create green, clean energy, electrical energy. And the beauty about this type of technology, unlike diesel type power or mechanical process generators, is that you have to really rely on all of these moving parts to all work in unison, not only from the internal components of the diesel generator, but then you also have auxiliary pumps, fuel tanks, transfer switch, and all these different things all have to work simultaneously in order to make something work. In contrast with that is that a fuel cell uses, as I mentioned, strictly a chemical reactive process. This type of technology is actually the same type of technology that was used on the NASA space program back in the 60s to generate power out in space. If you consider what NASA's mission is, you have to have two primary attributes that really would make this thing functional and valuable to NASA. The first one is that the system has to be extremely reliable for obvious reasons, and it also has to be extremely simple because, you know, if there's any kind of repairs that need to be done, the astronaut team is going to have to figure out how to make it work. So with those two attributes, GenCell decided to create a technology that's designed to support mission critical equipment, okay? Now, part of that is that we created, well, if you look at it from a typical fuel cell, is that the number one question I typically get asked is, if fuel cells are so awesome, why are they not more prevalent in the industry? And the reason for that is because of the accessibility of hydrogen. Today, hydrogen is still somewhat elusive. It's something that you have to pretty much be intentional to go and obtain, unlike just regular diesel fuel or gasoline. So it has to be something that really has to be planned. And when we started building the technology, we saw those as limiting factors that in order for us to overcome this and really make this technology mainstream, we had to overcome these types of challenges. So we created a solution called the A5, which is our newest solution based on obtaining the necessary hydrogen from ammonia. So don't be scared. I know ammonia sounds real scary, just like hydrogen sometimes sounds very scary for some individuals. But ammonia is actually very common in the marketplace, particularly in the industrial sector. Ammonia is the second most produced chemical in the world. It's readily used for agriculture, so the farmer, the agriculture community is currently using this on the farm, so they know how to deal with it. You're looking at water purification, semiconductors, plastics, many other types of industries use ammonia. So the supply chain is already in place, the safety protocols are already in place, the equipment is already in place, so it's a very good material, but the best portion of the ammonia solution is that it's highly, highly concentrated in hydrogen. It's actually, if you look at the chemical composition of hydrogen, it's 3 parts hydrogen, 1 part nitrogen. So as a fuel carrier, it's the ideal fuel because even in the US and many parts of the world, there's already pipelines providing ammonia throughout the country. So whether every country has it around the world, whether they produce or they import it, everybody has it because of what I just mentioned in terms of the usability of this technology or of this material. So now going back to the actual application of how we utilize this material. So GenCell created what we call a cracker. The cracker basically, if you're familiar with electrolysis, where you take electrical energy and water and you're able to split the molecules between hydrogen and oxygen that makes up water, we're doing the exact same thing, but we're doing it with the ammonia molecule. So with this process, it gives us the ability to bring in low-cost fuel that is readily available pretty much anywhere in the world. And now you're basically bringing it in the same way you would bring in diesel fuel or gasoline. So you would have basically a 10, 12 ton, or actually maybe 12 to 15 ton tank full of ammonia. And also given that it's a closed loop system, you don't have any issues about contamination or having large amounts of fuel on hand like you typically would have with diesel fuel, that over time, you know, it could get contaminated, you know, depending on the environmental conditions, and then you have to treat it. There's just a lot of issues dealing with fuel, not to mention that a lot of people will steal it in some of the applications that we're talking about in terms of rural applications. Nobody's going to really steal your ammonia because that's a specially handled material, but it gives you the ability to store it in large volumes so that when you're looking at savings, the fuel cell with the ammonia solution gives you the ability to reduce the overall logistical nightmare that you're going to have as far as taking fuel from point A to point B on a regular basis like you would with diesel or whatever common fossil fuel you're currently doing today. So literally, if you were to bring in a 12 to 15 ton tank of ammonia, you could literally run for an entire year without having to worry about fuel. That's one of the biggest advantages that you have, not to mention that all the other great attributes that I'll get to in just a second about fuel cell technology. But this really kind of revolutionizes the way and opens up a lot of options, because I know that when we're dealing with rural sites, logistically getting materials, whether fuel or otherwise, to some of these sites is very complex. So the more or the less that you have to transport fuel, as far as the logistic aspect, the less you have to deal with it, the better. So this really type of material really kind of opens up now the world to be able to use hydrogen fuel cell technology in a way that was never really able to be done in the past. Now, when you're looking at our technology, is that we have both a solution for primary power, and we also have one for backup power. The backup power is basically the same unit as the primary power. The primary distance is really how we're getting the hydrogen. So when you think about a hybrid solution between a UPS and a diesel generator to provide the instant power as well as long-term power, we created kind of a hybrid solution that gives you the benefits of both applications. So when we're applying this in a backup power scenario, the system is able to provide that instant power where your electronics will never know the difference that you went from fuel cell power, from utility power to fuel cell power, and it'll give you the ability to have instantaneous power, and at the same time with the generator, it gives you the ability to run for long periods of time. This technology has been well recognized not only by the Hydrogen Europe, the African Hydrogen Partnership, and we were also recognized last year with the GSMA as far as the green mobile solution that we created with the ammonia solution. So when we're talking about, overall mission critical equipment, the locations where we're typically operating in a telecom environment where, the expectation is that you have to drop off equipment and then hopefully everything runs correctly, because you don't typically have people around on a regular basis to make sure that all systems are operationally ready. So as Roy mentioned earlier in his assessment about how he's managing all his equipment through like a typical SCADA system that you're kind of monitoring and measuring different performance of all the equipment on the tower, is that we kind of have to do something very similar, because if you look at it from the power perspective, is that you need to ensure that the power source is making everything else that Roy just mentioned possible. And the way we do that is we also created a software platform that has open architecture. It gives us the ability to interconnect all the sites simultaneously. So similar to the way you would look at an IoT related type system that you might have multiple systems operating, and then you have like a Google map that has a point for every single installation, we have basically that same type of concept. And what this does is that the system is able to monitor and measure the performance of all the attributes that we have internally through a predictive maintenance attribute that we have within the system, so that as we're commissioning these systems, it has very specific parameters that we optimize the performance per environmental conditions and many other things, so that the system is constantly monitoring itself to understand that it's meeting the expectation based on the parameters that we put in place initially. So if there's any deviation in any of those parameters, the system automatically recognizes that and will start sending out an alert via email, text messages, beepers if you're still using beepers, any which way that we can communicate with you to inform you that, hey, there's something that's happening with the fuel cell, so that then you can go back and basically try to rectify the issue in real time. Now, how do we do that? So this system also gives you the ability to log in remotely anywhere in the world via your computer, laptop, smartphone, doesn't matter. And the system will give you the ability to basically, the same way we're connecting right now through Zoom, is that we can connect with the fuel cell and understand what are the parameters that are in jeopardy. If you look at the screenshot that we have there, that is a representation of everything that's actually happening inside of the fuel cell. So quickly, you can have our technicians go in there, as well as technicians that are part of the customer base, and they can go in there and identify exactly what is the problem. So by this time, as we mentioned earlier, is that by that time you will know which part is in question, what tools are required, how much time is it going to take in terms of expertise, or what type of expertise will be required to make this exchange. So you will basically already have a mission that you will go out to the site the first time with all the gear that you need, with all the expertise you need in order to rectify the problem immediately. Now, 70–80% of the time is you're going to be able to fix any of these issues electronically, because again, this is a computer pretty much that generates power. So 70–80% of the time you're going to be able to do what you need to do remotely, and that extra 20–30% is when you physically need to send somebody out there. But the idea behind this is to, from an efficiency and cost savings perspective, is to understand what you need to know and when you need to know it. So this really kind of gives you the ability to manage your process, better plan, as we discussed earlier, and make sure that power is never a limiting factor. Now, we can also connect this to all your SCADA systems, so that, part of typically what I find is that everybody's managing all of these different systems, but the power section is usually the one that's the missing link, and in my opinion, is one of the most critical components. So now having to complete the chain of what's happening with the power source, along with what's happening with the other equipment, really gives you the ability to fully understand what's happening with the entire system and make more informed decisions.
Thank you very much, Alex. Thank you very much. Indeed, very, very interesting, and really leading us into our first panel discussion, which is how critical is to monitor all site components, power, Node B, and satellite modems, VSATs. I think, Christoph, again, you are the guy that see the whole combination together at your labs with the Plugfest. And again, really interesting to hear if you see a value once everything in one shop, and you see the combination within the thing, and then only once thing really going bad, you can drill down into the management system of the actual equipment from the overall management system.
So I think I hinted to that answer before. Having everything monitor, it's critical. Having everything monitor in one common interface for a training point of view for the maintenance personnel, very critical. The other dimension, we also need to have some priority. And we were talking about power. Power is everything, but power is also something that can be managed. So having a way to monitor everything, yes, definitely critical. Having something that allows us to monitor and do predictive maintenance. When do we need to go clean up the PVs? When do we need to refuel that tank? When do we need
reducing the
things that are also very, very critical?
Is it also something that can help in the day-to-day maintenance and monitoring?
So first of all, it is critical as far as I see it. All the components need to be monitored today. The technology allows to monitor and also to keep the data for very, very long time. It is important to use that data to optimize all of the time. Not just see, some immediate faults or thresholds crossing, but look at the data for a longer time, and thus being able to detect maybe some power fluctuation or do a trend analysis, and then maybe something is going to get faulty eventually. And I think it is also critical to have the and the configuration parts of the system to be based on the same models. So not having a separate monitoring system from the activation and the ZTP system, but have sort of an end-to-end view that allows, for example, some problems in the monitoring detected the monitoring to be immediately correlated to some configuration changes that can be applied in order to fix some issue. That's, I think, one of the key monitoring aspects that that a management solution should bring to the table.
Thank you very much, Ray. Next slide, please, Christoph. And this is basically taking us into MorningStar and immediately into the next poll question. So back to you, Brad.
Thanks very much, Roy. I'll go ahead and address this poll question since it's so relevant to what I'm going to be speaking about. If everyone can just get a chance to make your selection, it looks like all the data is mostly in already. So I'll go ahead and talk about what we're seeing here. This is sort of the reason I asked the question in such a way was because this is very much how we see a lot of the categories of our customers across our industry and how they're managing systems. And we're seeing, obviously we're interested in more on the later terms that are a lot more sophisticated. But right now, of course, data for everything at the site is really critical. And we're also trying to support even some comparative or site data that gives like a third-party reference, such as not just monitoring our charge controller, but monitoring a solar irradiance sensor, so we have some way to compare it. But when you look at the answer in the poll here, you can see that still the majority of the respondents are in the categories of either they're not monitoring power, so they know that the power goes down only when the network disappears, or they have basic notifications and possibly battery voltage or power levels. But what we want to try to see is more of a path towards, as Roy had said earlier, moving into long-term analytics, long-term data analysis, trying to model and understand how you can predictively see when you're going to need a site visit. And then lastly, as we get more data into the cloud, with connectivity in more powerful servers and more capable ones, you'll see a few cases where we've recently had discussions with a customer that was looking to link up or do integrations to provide analytics or type of machine intelligence, because they just had so much data to go through that there was no way they could manage it themselves, just visually. They needed something that would look for those anomalies predictively and let them know. And we're starting to see that type of site analysis come into play. But in order to enable that, you need the data, you need the APIs, and it has to be open. Yeah, so in terms of where that's headed, that trend needs to move much more into the higher end of more sophistication, and that's going to get your operating costs down. So the example I was going to give was with batteries, of course, being a major cost of the system component, depending on the size, you're going to see pretty specifically detected data that's going to indicate when you have a battery failure. Like, to give an example, we had a recent site where there was extensive data logging going on. They saw multiple pieces of data that pointed clearly towards current being consumed in almost a short circuit scenario by the battery, an immediate drop in voltage, no performance by the load, and a disconnect in this case threw off some faults. And that was something where they would know that they didn't have to go to the site to even check. They knew immediately that there was a battery replacement needed. It was one site, it was a field replacement, and they were done, and it was warranted because of that data, because you can't argue with that kind of clear information. So getting into the slide deck, some of the things that we would typically determine when we have this long-term data storage available to show us what we can learn about a site over several years is, first of all, that initial benchmark at the site. In other words, some sites, depending on their location and their performance or the load demand, they're going to behave differently. Different modules, perhaps there's even some defects that can be determined early on, but you need a nice baseline for what that power system is going to consume and what a typical day looks like when operating conditions are good. Okay. And of course, is the load consuming what you expect? If you're getting into longer periods of time where you're seeing outages, loads that shut down, where you're actually losing radio connectivity, is it temporary? And it's just you had a bad day, you had 2 or 3 days of inclement weather and you lost the load? Or is it something where you're consistently seeing a degradation, the load is happening, is being disconnected more and more frequently, that's indicating problems with the site that are going to need to be addressed? Hopefully you can stay ahead of that even occurring, but at that point, it's no longer a fault or a wiring or a product issue. It's clearly a storage issue, an energy issue. So also, when you're able to look at the ratio at the site of the amount of power coming in from the PV to the amount of consumption, is that fairly well balanced? And is your battery a sufficient enough vessel to maintain that balance? If you're cycling on the high side of the battery, the upper 20-30%, the battery's going to have an extremely long life. You can look at the impact on cycle life of the battery. It can be doubled or tripled if you only shallow cycle it. Okay, but if you're seeing extremely deep discharges, that's going to provide, especially in the case of lead acid, pretty significant aging, and you're going to be able to detect that early on, because you're going to see this long-term stair step sort of downward spiral of the total energy. And then lastly, effective operations and maintenance, it requires load data as well. And as I had been in a previous panel and it talked about having a good profile of when that power is used, what the demand by the users has on the impact of, what's happening with the RAN as well as the VSAT, knowing what your expectations are there, because it can vary quite a bit. This is actually a fairly consistent power profile. We see a lot of equipment in other industries where there can be extremely heavy loads that come on for instantaneous time periods and then turn off again. And those are very hard to predict. So in touching on the theme of what we talked about with integrating to the NMSs and bringing everything together between multiple vendors, we had been using, automation and control systems, SCADA type applications, and of course Modbus for a lot of our high speed control. But needing to unify the communications, knowing that the monitoring was key, even if it was a simpler monitoring, just getting it out there, as we saw from the poll, just getting people that information. The NMS family of software monitoring tools and speaking a protocol that Telecom could really get behind is what we wanted to do. So that's why we put in a really lightweight data system, in this case, our EMC product. It's a really simple gateway. I would not even refer to it as a mini PC, like a Raspberry Pi. It's extremely lightweight, talking very lightweight serial to the device to keep that power consumption down, and then giving you IP-based data. You could still use Modbus management for control. You can use SNMP to blend into your single pane of glass and your NMS. There's even a web GUI that you can use for local management, because everyone's needs are different. They don't always have quite the large resources. And we work with a lot of other small wireless service providers that are doing things on a budget. So really having that connectivity, and then also referring to active load management, when you see an incident occurring, there's things you can do about it, not just monitoring the data and saying, well, our hands are tied, we have to go to the site. You can actively get in there, change settings, extend the load to run during a longer period of time, even if you sacrifice battery life. Perhaps actuating a generator or a fuel cell to take over if it's a backup application. Solar might be good for 95%, but not 100% of the time. And then lastly, problematic loads, being able to cycle power, troubleshoot equipment. All of that can be done proactively if you have hands-on control of the power system. So to summarize all that, here we get a little bit of side-by-side data, power data on the top, network data on the bottom, same software package. And in this case, this speaks more to looking at the long-term trend analysis. The granularity of the data that you actually gather is pretty critical. We've seen everything from every 15 minutes to hourly polling, to extensive sites where they're looking to really model a type of system, and they want extremely high granularity of data, meaning polling every 5 to 10 seconds. Because if you don't have the resolution, you will often miss transients or things that occur in the power system that just won't get picked up because you didn't sample at a high enough rate. And that's extremely useful to be able to catch that. But as we know, we're on often limited bandwidth, and we don't want to bog down and take over user capacity with administrative overhead. So we have to be careful. But anyway, graphing some of that data gives you some of the explanations here, such as insufficient power levels during bad weather. Obviously, there's not going to be any snow on PV modules in the climates we're talking about for these system deployments, but it's a real problem in a lot of areas, especially in the more northern latitudes. Also looking at battery state of health, not just state of charge, but is that battery nearing the end of its life? Is it no longer able to hold a charge? As I said before, is the voltage swinging rapidly during charge and discharge cycles, which can indicate that there's a bad cell, or that the battery's just no longer meeting the capacity requirements of the site. And then also recurring alarms that are indicative of other problems. More often than not, we rarely see panels with manufacturing defects, but we do see panels that have typically been vandalized, stolen, disappear from the site. Being able to detect the lack of PV, not just poorly performing PV, is also a major issue. So anyway, and yeah, so that kind of sums up, how you can, if you look at the overall investment, a number of years can be saved, especially with lithium. We've got extremely long panel life, and now a much longer battery life with lithium capacity coming into the industry. So doing the right design up front, you're going to see a pretty big change at the end of that life, anywhere from 7 to 10 years or more, if things are done right from the beginning. So Okay, thanks very much.
Thank you very much, Brad. So basically, this is taking us into the Q&A session for the audience. So how do you see NMS contributing the rural deployment OPEX reduction? Very interesting one. I think that indeed one of the interesting topics beside the technical aspect, and in order to reduce complexity, the OPEX, this is the the big question mark. So OE, you touch it a little bit, but maybe you can answer this question.
Yeah, so there are various, I would say, aspects to this. Each has its own saving factor, and of course, you cannot really achieve immediately all of the savings, but I would say the three key things are zero-touch automation, which allows to automate as many configuration as possible, both in day zero, but also on the average life cycle of the whole site. You will have to do some software upgrades, some radio configurations over time. You will have to swap some elements, and you would want to have this the configuration reapplication to be done automatically as possible. The monitoring can bring a lot of OPEX saving if it's done correctly. It doesn't just bombard the users with just tons of faults and counters. We cannot really make a sense of. So here, really automation has to be done in a new type of technologies and system that can really make the correlation and particularly identify the root causes of the use events that are coming. And lastly, as I've also mentioned, I think really the integration to the other ecosystem solutions and platforms that are running at the OSS and BSS systems of the operator is also mandatory. You want to make them once and not multiple times, and thus really save on OPEX over a long time.
Thank you very much, Roy. We have another question that comes. Have you experienced challenges around connecting NMS to the interface of legacy MNO network? Roy, I think that again, you are the...
Yeah, so of course, a lot of challenges here. You can find really in the networks today a plethora of different APIs and behavioral models of different elements. Indeed, it is very, very challenging. You cannot just, in my opinion, bring a solution that manages just one silo of the network and then another solution that manages another silo and so on. You will end up with having more management systems than actual elements eventually.
Yeah.
So yeah, one of the key challenges is having a solution that combines all of the different technologies and vendors, legacy and new stuff all together.
Thank you very much. I believe that Brad and Alex, also you guys are getting requests from your customers to expose, standard API in order to allow the management system to indeed collect all the traps, alarms, PM reports, and etc. in order to allow a single management system that can handle this mess in rural site deployments. Is that right?
Yes, so from our side...
Let's start with you, Alex.
Okay, yes, from my side is that you're absolutely right. And one of the things that I mentioned earlier about having the software platform that has open architecture characteristics about it is that it's not just managing the fuel cell itself, is that we're also able to incorporate other IoT related type sensors. As a key example, we talked about, and I know that's been a hot topic in this whole session, about safety and security of the equipment. So literally, we could actually put in access control technology. We could put in infrared technology. If you want to understand how to turn on and off air conditioners or other type of systems that are necessary, all of those systems are potentially be vital to the operation of our power source. So when we're looking at the total picture in terms of how do we make sure that power is never a limiting factor, is that not only are we working with the best possible fuel source as far as a fuel cell from a hardware perspective, but then from an electronic perspective, we also need to understand what is the environment, what's happening around the environment, which also could potentially impact the power source. And then, as you mentioned, Roy, is that if we're able to upload all of this operational data in real time, that also gets incorporated into what Roy is doing in terms of managing all these SCADA systems and legacy technologies and all those, you're really kind of completing the entire circle that includes everything that you're managing today, but always typically is the missing link is always the power source. So now that you're able to put in the power source in conjunction with what these other systems are managing as it is, now you can really, as a management company, you can really manage the entire operation and really make informed decisions, not only for better planning, but better execution of resources when they're mandated. So we feel that, this type of technology is going to be vital, not only for rural applications, but also in non-rural, because at the end of the day, if you're managing thousands and thousands of sites at a time, you would have a whole department full of analysts trying to decipher all of this data, make sense of it, send somebody a report, and hopefully somebody takes action on it. So the ability to kind of collect all of this data in real time and be able to provide the real-time alerts to say, hey, you don't have to worry about the entire network, but you do have to worry about this specific site. You're kind of honing in at the granular level in order to ensure that that specific site is not the weakest link out of the whole network, if that makes sense. So I think that, the more we get into these technologies, and I think, all my fellow panelists here, we're all saying the same thing, is that operational intelligence is vital to this type of operation.
Yep. Thank you very much, Alex.
If I could add to that, one of the things that we see, Roy, is we actually get a lot of requests for integration and partnership with other products because of the dynamic nature of solar. Because solar, given that you don't always know what you're going to get day to day, but you can possibly predict it or get an idea over time, they want to partner with us to get access to that information so that we can work more collectively together. An example would be if you have a grid hybrid site with solar and the grid combined in weak grid areas, or if you have a system that was previously 100% genset run, these are larger hybrid systems, then adding solar to that and actually communicating with the solar system, you can provide optimization and balance so that you still have really strong uptime for your site, but you're minimizing the generator, and they're not colliding with each other. They're working dynamically. And we've even seen, of course, some looking into predictive weather patterns to say, well, tomorrow there's not going to be good solar performance. Run the generator now, get the battery to a healthy state. Don't get behind tomorrow. And we're seeing that types of optimization occur when the data is shared. Thanks.
Thank you very much. Gentlemen, I would like to thank you for your time and this interesting panel. I would like also to thank to the audience that joined us. I'm encourage you to go to the booths, to the virtual booths right after the panel. So again, thank you very much all. See you.